Hello, this is Matt from Matt Heaney Apps. In this video, we are going to take a look at a really important area of Swift, protocols. Now, protocols are somewhat of an intermediate topic when it comes to Swift, so make sure you have your basic Swift down and nailed to get the most out of this video. I know on this channel we're halfway through the Introduction to Swift UI series, but honestly I just really fancy teaching some Swift code skills, so let's do a few of these videos before jumping back into that series. So here I have a blank playground in Xcode 12.3 all set up and ready to go. So boot up a brand new playground area and let's get to work. So, protocols. Protocols are an essential feature in Swift, to the extent that Swift has been described as a protocol-orientated programming language instead of just an object-orientated programming language. So it's a really important area to know when it comes to using Swift. With protocols, we list a number of properties and methods, so just functions that belong to an object. Then we can take objects, so classes, structs or enums, and make them conform to this protocol. By doing this, that means that that object must have all of the properties and all of the methods listed in that protocol that it is conforming to. That gives us a lot of advantages, which we'll look at in this video. Protocols are a great tool when there is a has-a relationship. You can have a number of different objects which are completely separate, but they should all have something in common. Using a protocol, we can make sure these completely separate objects all have certain properties and methods. So let's take a look at this in action. For this, let's pretend we're making a shopping app. In our shopping app, the user can buy a whole bunch of stuff. But for today, we're going to focus on two particular products: books and video games. Both of these items are completely different, and they are not related in any way, except for one big thing they have in common. They can both be purchased by a user. They are both purchasable. Let's set this up. So in our store, as I said, there's two real items that we care about today: books and video games. So let's set up brand new classes, one to represent a book and one to represent a video game. So let's have class, book, and we're going to be adding properties to this class as we go throughout this video, but for now let's add a property that is unique to a book. Let's add a constant called number of pages, which is going to be an int, right? So a brand new class called book, and any item that is a book will have a certain number which represents the number of pages in that book. As this is a class, we need to set up our initializer. So when we make a book, we're going to pass in the number of pages, which will be an int, which will simply set this value here to this value here. It's a simple class initializer. As I said, the other item that we care about is a video game. Just like books, we're going to add some properties to this class as we go throughout this video, but for right now, let's add one property that is unique to video games. Let's add a boolean for if this video game has an online mode or not. So online mode, which will be a boolean, and again, let's pass this in through an initializer. Just like so. So we now have these two base items set up in a very basic way. And they're completely separate, right? Books don't really have all that much in common to video games when it comes to the properties that make those items either a book or a video game. But the one thing these things do definitely have in common in our example today is that they both can be purchased through our store. Any instance of book or any instance of video game can be purchased. Now in our example app, we want to make sure that any item that can be purchased by a user has three very important things. We want to make sure that any item that is purchasable has a name, otherwise our ordering system is going to be a mess. That it has a price, very, very important for the user, and it has some logic to actually be purchased. We want to guarantee, make 100% sure that any item that can be purchased has those three things. This sounds like a good use for a protocol. So before we set up our classes, in a real life app, it doesn't matter where you really put this, but in a playground, we have to put this above our classes because it will be used in these classes. What we will do, we will make a brand new protocol. This protocol will be called purchasable. And this protocol is going to list those three things. And this protocol will be set up to pretty much say anything that is purchasable must have these things. This is the perfect place to have our properties for name and price, and to say that anything that is purchasable must have that logic to be purchased, right? Now, the really important thing about protocols is that we don't put any implementation here. This is the blueprint, the contract that objects can follow. So for example, our purchase method will look like this. It'll be a function called purchase that won't take any parameters. And at the protocol level, that's it. We do not add logic here. All we will do is say that any object that conforms to protocol, it must have a method called purchase. It can do whatever the hell it wants in that method, but it must have that method. Same with properties. We can set properties up here, but we don't give them a value. All we're doing in this protocol is saying that any class that conforms to this protocol must have this property. The object must use the type that we set here for this property, but other than that, the object can set any value it wants to that property. The one rule the protocol cares about is that it has it. When it comes to declaring properties in a protocol, things are a little bit different. Rather than using var or let, we only use var, and instead we specify the minimum behavior of this property for after when this object has been initialized. So after this object has its initial value. If we must be able to get the value of this property in our objects, then we can say this property is gettable. If we must be able to set the value, then we can say that this property is settable. Or if we must be able to set that value and get that value, then we can say it's gettable and settable. However, this is only the minimum required behavior of conforming objects. For example, if we say a property must be gettable and settable, then this property must be a variable in conforming objects. Because only with a variable can we get the value, so can we read that value, and set the value. So we can change the value. We can get it and we can set it. But if we list a property with only a getter, for example, then in conforming objects, it can be a variable or a constant, as both allow you to get that value. Sure, if it's a variable, we can also set that value, but regardless whether it's a variable or whether it's a constant, we're hitting the minimum rules laid out in this protocol. Important note for when it comes to setting, initializing the property with a starting value doesn't really count as setting, you're just making that object with a starting value. Setting relates to updating the value once it's been made. Let's see what I mean. So we'll say var. And remember, one of the properties that we really care about is that any item that is purchasable must have a name. It's going to be a string. Chances are, once this value has been set, it won't really change. So we don't want to make it a requirement that this value must be settable. However, we are going to want to be able to get this value to use it. So we will mark this as just gettable. Objects can set the value if it needs, but it's definitely not a requirement. So between curly brackets, we will say get. Any object that conforms to this protocol must at the very least allow us to get this value to use it. On the other hand, the price, which will be a float, so a number with a decimal point, we will mark this as gettable and settable, meaning that conforming objects must allow us to both get and set that price. This is important because prices will probably change in our store. So any item that is purchasable must allow us to both get the price and set the price at any time. And that's it. No initial values, no initializer, just this. Remember, this is not an implementation. It's just that contract. So now any object in our code that conforms to purchasable, it must have a method called purchase, which will do something. The protocol doesn't care what. It must have a string called name, which we can get, and it must have a float called price, which we can both get and set. Now, it doesn't really matter what order we have here, but I always kind of prefer having my properties before the method. It just felt nice to explain the method first. So now let's use this protocol and let's see it in action. Let's take our book class, for example. We know our book has some properties that make it uniquely a book. It has a number of pages. But this book can also be purchased, right? So it will conform to purchasable, like this. And this will say our book object must have what we've stated up here in our purchasable contract in the protocol. Now straight away, we're going to get an error saying that book does not conform to purchasable. And that makes sense because our protocol says that any object, in this case book, that conforms to purchasable must have these properties and this method. Book does not have these things. We're going to get an error. So let's add these in. We want a constant called name, which is going to be a string. We could give this a value, but we're going to pass this in through our initializer. And we also want a variable called price, which is a float. Let's pass these in through our initializer. And let's link it all up. And the other thing that we care about is that book must have a purchase method. Again, it can do whatever it wants, but it must have that method. Now that we have this, our error is going to go away. Book successfully conforms to purchasable. Book now has all of the things that make it a book, but it also has all of the things that it must have to be purchasable within our app. As you can see, our purchase method is currently empty in the book. We can do whatever we want here. We can leave it empty, we can have the most complicated logic in our app, or anywhere in between. For today, we're just going to print a statement that says you purchased a book called, and I'm going to print the name of the book. Now we can do this across many items. For example, we can also do this on video game, where we can have the properties that we need. And the method called purchase. So now we have two different objects and two different classes, book and video game, that are completely separate, but they both conform to purchasable, meaning that both must have a name and must have a price, and both must have this purchase method. The implementation can be whatever that class wants. Now granted, they're pretty similar in this case. For example, the book will just print out a message which says you purchased a book called whatever the book was called, and the video game will print out you purchased a video game called whatever. The important thing is the protocol does not care about that implementation, it cares that object has that method. So we've now declared a protocol and two objects that conform to this protocol. So we've now set up a protocol and use this on two different classes. And this already shows one of the main benefits that protocols has to offer. Simply by using protocols, we're ensuring that classes that we need to have certain things is guaranteed to have those certain things, right? If we want to have an item that is purchasable, it now must 100% have all of the things that we need to make it purchasable. We can't leave one out by mistake. We can't say price is a double rather than a float, for example. It must have what we need in the correct way. That is pretty cool. Now another cool thing about protocols is that we can make any object conform to a protocol. So we can make a class conform to a protocol, we can make a struct conform to a protocol, or we can make an enum conform to a protocol. Additionally, objects can conform to multiple protocols. For example, a video game could be purchasable, as well as, for example, playable, completable, savable, whatever we need. We can stack up different protocols by just having a comma and adding another protocol. Also, important note for when it comes to classes, a class can still inherit from a superclass as well as conform to a number of protocols. Now, one of the biggest benefits that comes from using protocols is that the protocol itself can behave as a type. Let's take a look at what that means. To see this in action, let's create a few instances of our books and our video games. So we might have book 1. This initializer feels like it has a bit of a weird order now because of the way we put these in as we worked through this tutorial. So let's jump back up to our initializer and flip this order around. And flip these round. Same in the video game. Sweet, so let's make a new book. This book could be called something like Intro to Swift. Price is going to be $49.99. Number of pages, 300. Let's have another book called Advanced Java, which is $89.99, 900 pages. It's a chunky book. And let's make a few video games in here as well. And let's have something like, I don't know, like GTA, which comes in at $49.99, which does indeed have the online mode. And another one, this time Uncharted, bit of an old game now, but I still love it. Like so. Now we know that book and video games are types of objects, right? So for example, we could have an array of books. And here we could have book 1 and book 2. No surprises there. We could also have an array of video games. Again, no surprises there at all. But the cool thing is that we can now have an array of items that are purchasable. We can use the protocol as a type for our array. And now we can have all of our items together in the same array. We can have items that are of type book and items that are of type video game together because they are all purchasable items. However, something interesting happens here because items in our purchasable array will actually work a little bit differently. Let's take a look. So let's go back to our books array. Let's get the first item out, so the item at index 0, book 1, and let's get the number of pages for that. That works fine, right? We could print this, we could use it in a statement, we could use it however we wanted it. Now book 1 is also the first item on our items array. But remember, items is an array of purchasable items. So here, we now do not have access to number of pages, which feels a little bit weird at first, but it makes a lot of sense. Sure, this item here in our items array is a book, so it should have number of pages. But remember, this is not an array of books. This is an array of purchasable items. So anything on this list must conform to purchasable. It could be anything. It could be a book, could be a video game. It could be any object we set up to conform to purchasable. This array does not care what that type is. It just cares that it's purchasable. And because of that, it will treat each of these items as a purchasable item. Not the actual type of item it is, it will only treat it as a purchasable item. So because of that, we can only get access to the properties and the methods that we state in our purchasable protocol. So we could get the name, the price, or run that purchase logic. If we wanted to get the number of pages from this item and treat it as a book like it is, we have to typecast this. So we could do something like let book equals item index 0 as a book. It will say go to this array, get this item, try and typecast that to be a book. If you can, set that to book. If not, set it to nil. Now we can treat this as a book item, just like we expect. But if it isn't a book, if it's a video game, this will be set to nil, so therefore this can't run. So we can either wrap this in an if let, we could wrap it in a guard, or we could force unwrap it like so, but best not to do that. Or we can do as a question mark to either return the item as a book or return nil. So that's one of the really cool things about protocols. We can use it as a type, just like so. This, of course, does not stop with just using a protocol as a type for an array. We can use this anywhere we would use any other type. We could, for example, use a protocol as a type for a parameter on a function, or we could use a protocol as a type on a property in a class, or anywhere we would use a type, we can use a protocol. When it comes to protocols, there's one more thing I want to show you in this video, and this is how we can use an extension on a protocol to implement some default behavior for any object that conforms to a protocol. Let's take a look at what I mean. So far we know that a protocol will just be pretty much the contract for objects. There's no real implementation here. So for example, purchase has no implementation. It's a method, but there's nothing here. That implementation is left up to the object to do whatever it wants to do in purchase. The protocol's job is just to make sure that any object that conforms to this protocol has this method, right? But sometimes we want every single object that conforms to a protocol to have a method with the exact same implementation. So say for example, we wanted all of our purchasable items to also have a restock method, but every single one of these implementations is going to be the exact same. No difference at all. It will just take an item and it will restock it. So what we could do is declare it here in our protocol, then go through all of our objects that conform to purchasable and implement the exact same behavior. That feels wrong, right? Obviously we only have book and video games here, but imagine if this was a real app. Imagine if it's a real store. Imagine if it's Amazon. Imagine how many different kind of objects there's going to be. You don't want to go through every single one of them implementing the exact same logic. So we want to find a way to have this same logic in all of these classes. We could put this logic perhaps in a superclass and inherit down to all of these objects. That might work, but the problem is we don't really want to do that because these items are too different to have one superclass. So what can we do? what we can do, we can actually use an extension on our protocol to implement some default behavior. So rather than putting this here, well, we can't implement some behavior here, what we would do, we will add an extension on purchasable like this. Now, if you've never seen an extension, it's pretty much a continued version of what is here. So there's a few different rules in the extension, but pretty much it's a continued version of purchasable. It's an extension on purchasable. Now, when it comes to protocols, the big thing with extensions is that we can declare methods and we can give it an implementation. Let's add a brand new method here to restock an item. Any item that is purchasable must be able to be restocked. Makes sense, right? It might sell out, we're going to restock it. No parameters, no return types. But now, because we're in the extension of our protocol, we can add a default implementation. Now, in the real world, we would do some logic here to purchase some items to pop into our stock. But for now, we are just going to print restock for item name successful. So in addition to having this default implementation, we can also use these properties up here in these methods. Anything that is purchasable must have a name, right? So we can use the name property. So by using an extension on our protocol, we have added one more method called restock with this implementation here. Now, any object that conforms to purchasable will automatically get this method, and it will do this. Any of them. Doesn't matter if it's a book, doesn't matter if it's a video game, it can be any object that conforms to purchasable. It will get this. So let's have a look. Back to the bottom. If we was to take book 1, for example, which is a book which conforms to purchasable, in addition to name, number of pages, price and purchase, we now have restock. Same on book 2, and same on the video games. If you was to run this, when we run restock on book 1, it would print to the console saying restock for Intro to Swift successful. For book 2, it would say restock Advanced Java successful. For video game 1, it would say restock GTA successful, and so on. It's a default implementation for any object that conforms to purchasable. We can also use this on one of the items from our arrays. So index 0 of books, which is an array of books, as I'm sure you remember. Also can restock, and we can also do this on our items in our purchasable array because they're guaranteed to be purchasable, so therefore they're guaranteed to have this implementation. And just to prove it, there it is, just like so. So using an extension on a protocol, we can implement some default behavior into any object that conforms to a protocol. That is pretty cool. So that wraps up our look at protocols. If you have any questions or any comments, post them down in the comment section. Or if you have any Swift areas you want me to cover in one of these videos, also let me know down in the comment section. If you liked watching this video, which I really hope you did, make sure to hit that like button, hit subscribe, and I'll see you next time. Goodbye.